What is projectile motion? Projectile motion can be expressed in two ways. The first one is when a particle is thrown obliquely near the Earth's surface, it moves along the curved path under constant acceleration, that is, directed towards the center of the Earth. We assume that the particle remains close to the surface of the Earth. This is important. The path of such particle is called projectile and the motion is called projectile motion. Once again I am reading. When a particle is thrown obliquely near the Earth's surface, it moves along a curved path under constant acceleration. That is, directed towards the center of the Earth. Remember, we are assuming that the particle remains close to the surface of Earth because acceleration due to gravity remains constant at the surface of Earth. The path of such particle is called projectile and the motion is called projectile motion. Let's see another definition. It is a two-dimensional motion, both horizontal and vertical, exhibited by a body under the influence of gravity is called projectile motion. It is a two-dimensional motion, both horizontal and vertical, exhibited by body under the influence of gravity is called projectile motion. But here, when we are talking about projectile motion, we are going to consider only gravitational force. We are going to neglect the rest of the forces like air friction, buoyant forces and all. So that's a very important note point. So during projectile motion, only the force of gravity is considered and other forces like air resistance, buoyancy, etc. are not considered. So remember this point. So let us see. When you project any body in two dimension, both x and y, the body basically undergoes a force towards to the center of the earth. Therefore, the path of the projectile B appears to be as the parabolic path. So here projectile is exhibiting two independent motions. One is along x-axis, other one is along y-axis. And since there is no air resistance along x-axis and y-axis, along the direction of x-axis, the particle exhibit uniform motion, and whereas along y direction, particle exhibit uniform accelerated motion because acceleration is acceleration due to gravity. Let us see how a projectile motion exhibit parabolic path. So I am going to draw y and x axis. Here I am projecting a particle from the origin with a velocity u at an angle theta with x-axis. So here a particle is being projected in both x and y axis. Therefore, the velocity vector along x direction will be ux, which is u cos theta I cap, and velocity vector along y direction will be uy, which is u sin theta j cap. And since there is no supporting force or opposing force along x direction, therefore acceleration of a projectile along x direction will be 0. But whereas acceleration of a projectile along y direction will be, it is due to gravity, which is always acting towards downward direction, let it be minus g. After an instant, horizontal velocity remains constant, which is ux, but vertical velocity decreases because during upward direction it experiences retarding motion. So let this be vy dash, and the net velocity will be this side. And after an instant again, horizontal velocity remains constant, but vertical velocity will be reduced to vy double dash. So therefore net velocity become this much. And at this point, when you observe, the net velocity will be ux because the vertical velocity becomes 0 and horizontal velocity remains constant, that is ux. And that point we call it as maximum height. And from hereafter, the projectile completes half of the journey, and hereafter it is going to complete the rest of the half of the journey. Therefore, the horizontal velocity remains constant, but vertical velocity will be increased a small amount because the acceleration is acting downwards. Therefore, the net velocity will be this side. Thereafter what happens? Again horizontal velocity remains constant, but vertical velocity increases by magnitude. Therefore, the projectile will go like this. And finally, the horizontal velocity remains constant and vertical velocity increases. Finally reaches to the ground. And this horizontal displacement we call it as range. This is displacement along x direction, and this maximum vertical displacement we call it as h max, that is sy. Let us write the components here in x and y direction. Initial velocity along x direction is u cos theta, and initial velocity along y direction is u sin theta. And displacement in x direction, maximum displacement in x direction is range, and maximum displacement in y direction is h max. And time taken for both the journeys will remain same, but final velocity along x direction is always same because there is no acceleration and no retardation. But whereas final velocity in the vertical direction at any instant is uy minus gt, because during upward direction acceleration, the projectile is undergoing retarding motion, and during downward direction projectile is going accelerated motion. So this is how we need to calculate position, displacement, velocity and time.